just quickly go through some of the code which I mentioned through the software architecture. As you can see, it's a very simple project. There's not a lot of code associated with it. I'll just go through the layers. For instance, there's simply one class for the DAO. There's a simple class for the service layer, and associated with the agent is really one agent-based class, and associated with that is what we call a generic publisher, which all publishers are based upon. As you can see, I've got 3 example publishing agents in this code, but they're all very basic, and in fact when you actually run the code you won't necessarily call the code, you'll actually call a configuration file, and the configuration file will actually define how an agent is run rather than the code itself. So if you want to add a new agent, you don't have to write code, you create a new configuration file and define the definition from that agent through the configuration file. I'll go through a bit more of that later on. But as you can see, it's fairly simple. There's not a lot associated with the actual code itself. Most of it is managed by the SIFWorks ADK.
Is that simplified because of the .NET Common framework as well?
No. Unfortunately, the .NET Common framework was actually done after this particular piece of work. What the .NET Common framework did was it was based upon the work done for the NT agent. The agent configuration, as I mentioned, the SIF agent is defined by configuration rather than by code. So when you create an agent, you're actually creating a configuration for an agent, which the agent will then use to define its publisher. The way it's been able to do this is it's been able to use lots of SIFWorks mapping facility. This mapping facility allows you to take a database table or a data set which reads from a database table and map the values from the data set into the XML structure which defines a SIF data object, and which is then sent through HTTP to the ZIS. By doing this, the staging database then actually defines an interface for this agent to work off, as the information which goes into the mapping is defined by SQL, and this SQL is then transformed into a data set by C# code, which is then read and mapped by the SIFWorks ADK. So to actually run an agent, to run the NT agent, you run one executable, and on the command line you just basically pass in one configuration file, and that configuration file will then define how the agent reacts and works. I'll just go through an example of the configuration file. This configuration file defines the definition for a student agent. At the beginning, there are SIFWorks ADK specific properties which need to be defined. The agent configuration actually incorporates application specific properties and ADK specific properties, and these are the ADK specific properties. The next set of properties here define information which is specific to the actual agent itself, database connection details. These properties here define how a publisher runs for the agent. Publisher then also defines the type of SIF data object that's actually being managed by the publisher. In this case, as you can see, this particular agent definition defines a publisher for a student contact personal, student contact relationship object, student personal object, and student school enrollment object. I won't go through specific details about what each of these properties do. I just want to mention that these SIF data objects are managed by this particular publisher in this manner. This defines the frequency of the event mode. The configuration file also defines the URLs associated with the ZIS, and in this case the production ZIS used is a visual, but we have got at NSIP energy structures ZIS, an RM ZIS, and a visual ZIS. This section here is probably the most important section out of the entire configuration file. It defines how this particular agent publishes, for instance, student contact personal information. This section here is the section used by the SIFWorks ADK to manage its mapping, and as you can see here, it's got a name value pair relationship. So the name is the actual information returned. In this case, if you look at the SQL above it, defines a column for a table, and the value defines an XPath value to specify where that value goes to in terms of an XML message. So the SIF messages sent are actually XML messages. This XPath definition defines which part of the XML message that the data is going to go into. This section above, which specifies SQL, is specific to this particular agent rather than through the ADK. It's a proprietary system for getting the data from the staging database and into the mapping system. So for instance, when an event occurs and a message needs to be sent, this particular query is run, and if you look at it, it's just simple SQL. It will extract this information from the database in from these columns, and from this information is then passed to generate XML based upon this XPath definition. This information here at the back is an internal mechanism used to determine whether an object or row has been updated since the last check. The extract process updates order IDs as it updates new information, and this checks the order ID to see whether it needs to send current information since the last check. There were probably three main challenges associated with a SIF agent. None of these really are associated with the SIF code per se, more associated with processes around the SIF agent. The first one has got to do with the data management, which is mainly dealt by JR with his extract process. If the SIF agent had to manage these particular issues, the amount of code written would have been exponentially larger. The SIF agent did not have to worry about any sort of business or data, read the data from the database and pass it on. This made it easier for us to be able to use the SIFWorks ADK mapping mechanism, and because we use that reduced the code set by a substantial amount. Another issue was with data load, specifically with the student daily attendance. As I mentioned before, student daily attendance was disabled. That flows in for a student daily attendance record. When the Tri-Border project initially started, there was a small number of schools. The number of records read was manageable, but as the project scope increased and the number of schools increased, there was a substantial increase in records, which also caused load issues with the processes in terms of memory usage and in terms of the amount of time the process had to run to process these particular messages. To resolve these issues, a batch mechanism needs to be implemented. At this point in time, it hasn't, but the design has been available and is ready for incorporation into the agent, just hasn't been done so. Another issue was with security in terms of network security. Firewalls, ports had to be open for communication to the ZIS. Also, as we're communicating using HTTPS, there were issues with installation of certificates, and as you go to use, in this particular case, the agents were push agents. You only had to install certificates at one end, but when you're talking about pull agents, they will have to be installed at two ends for HTTPS. This is a large issue, but it can be a catch if you're not careful and you don't have the appropriate skills to manage certificate installation. And if you need more information on the actual SIF agent, there's the Confluence site that you can go to. Thank you.
Thank you, Raf, JR, and Jeremy. So that concludes this next in the series. Go back to the Confluence site, take a look. Thank you all for being involved, and we'll talk to you again soon.